Congratulations for bringing the course Introduction to Computer Science with MakeCode and microbit to your students. And welcome to this video, where you'll get a high-level overview of the course and instructional materials to jumpstart your preparation. Here's what we'll cover. We'll introduce the purpose and the goals of the course and look through the instructional materials that are there to support you and your students. We'll review the technical and material requirements, and then we'll walk through the most important preparation to complete before you teach. You might find it helpful to have the course overview guide and Unit 1 materials open as you listen to this video so that you can pause the video at any point to look at the materials or resources in more detail. This course introduces computer science and programming concepts with a maker philosophy and project-based approach to help students see coding as an important part of building creative solutions to solve a problem or serve a purpose. It features Microsoft MakeCode and the BBC microbit. Even if you don't have a computer science background, you'll be able to teach this course. You and your students are in for a fun journey as you work creatively with computer science concepts and build some awesome projects. Microsoft MakeCode is a free programming editor that brings computer science to life with fun projects, immediate results, and both block and text coding options to accommodate learners at different levels. The microbit was created by the BBC in 2015 as part of their Make It Digital campaign to encourage children to move from being consumers of technology to become actively involved in writing code and building new things. It's a pocket-sized computer with programmable buttons and an LED display that provides an easy introduction to programming and acts as a building block for all kinds of cool creations, from robots to musical instruments and more. For support, you have two go-to resources. Frequently asked questions are found at makecode.microbit.org/FAQ. The knowledge base, found at support.microbit.org/support/home, is a repository of articles written especially to help answer common questions and solve common problems. The course comprises 12 units, each focusing on specific concepts and skills that are mapped to computer science standards. You can expect approximately 22 to 30 hours of instruction or facilitation time. And there are approximately 16 to 27 hours of independent project-based activities for your students. Each unit comprises 3 lessons. Keep in mind that the length of each is approximate, and it's intended that they're broken down into as many class sessions as needed. The lessons combine 4 types of activities that complement each other by reinforcing concepts, skills, and opportunities for creativity at different levels. Lesson A includes an overview to introduce the unit concepts and an unplugged activity away from technology to solidify concept understanding in a tangible, kinesthetic way. Lesson B puts the concepts into practice with guided birdhouse activities where everyone codes the same program all together to focus on skill development. Lesson C is the independent project, where students apply the skills they've learned in new ways and exercise their creativity. The course targets students ages 11 through 14 and is designed to engage students with or without any coding experience by providing coding activities and optional challenges called mods, which is short for modifications. The course can also accommodate younger students of 9 and 10 with some coding experience or more advanced skill. By the end of this course, students will be able to describe and apply the following coding concepts: algorithms, variables, conditionals, iteration, coordinates, booleans, bits, bytes, and binary, radio communication, and arrays. They'll also be able to demonstrate that they can synthesize the concepts in new creative ways through self-directed coding projects. You'll find the unit-specific learning goals in the unit summary section of the course overview guide and in each Educator guide. In addition to this video, you have a variety of instructional materials that we'll review now. Feel free to pause at your convenience to look at any of them in more detail, then continue watching. Those materials include a course overview guide with an overview, bill of instructional materials, technical and material requirements, course delivery, required educator preparation, and a glossary. An assessment guide with descriptions of the 5 types of assessments, all answer keys, printer-friendly versions to distribute to your students, and scoring rubrics. A standards alignment guide that includes all CSTA K-12 computer science standards addressed in the course and each unit. And a high-level overview booklet to promote the course to stakeholders, such as school district administrators or government partners. Each unit has a short quick start video with a high-level introduction to the featured computer science concept, key preparation, and activities for that unit. An educator guide with an overview of the goals and standards addressed and any required unit-specific preparation and resources. For each lesson, there's a lesson plan outline, a before the lesson section with any prep tasks or required materials, a lesson details section with activity instructions and screenshots, and post-lesson assessments and reflections. A PowerPoint presentation that complements the content and activities, and a student workbook with the learning goals, activity instructions and tips, mod ideas, project expectations and scoring, and glossary of that unit's key terms. The technical requirements are found on page 7 of the course overview guide. The educator and each student will need a computer, laptop, or tablet with an internet connection, modern browser, and USB port, and a microbit, micro USB cable, and battery pack. To allow the project design aspects, additional accessories are recommended, such as crocodile clips, headphones or speakers, copper tape, and servo motors. Be sure to see this section of the guide for the complete list and purchasing recommendations. No special software is required because all coding can be done in the online version of the MakeCode editor at makecode.microbit.org. If your devices use a Windows platform, another option is the free MakeCode for Microbit Windows 10 app found at aka.ms/microbit app. To complete the projects, an assortment of arts and crafts supplies are also needed. See the guide for a complete list and purchasing suggestions. The required educator preparation starts on page 15 of the course overview guide. We'll start by reviewing care and safety tips. The microbit is simple and safe to use with youth. It's been specifically designed as an open microcontroller board with all the electrical parts on display, which also means there's a small risk of damage to the parts. So there are some safety tips. For example, it's important to avoid generating static electricity by keeping the microbits in the anti-static bag when not in use, and grounding or earthing yourself before touching it by briefly touching a metal object like a chair or table leg first. The full list is on page 15, including links to printable safety tips. Be sure to develop equipment safety procedures with expectations to store, distribute, and collect the microbit and accessories as you do for other devices. Before teaching the first unit, you'll need to master the course materials, understand the core concepts and terms, and know your tools. Now we'll highlight the most important tasks to accomplish these objectives. Be sure to review these sections of the course overview guide for all details. To master the course materials, start by reviewing the full course overview guide. You'll find descriptions of each unit starting on page 10. Review the Unit 1 materials in detail, and give yourself enough time to practice all activities before every unit. We suggest that you stay at least one unit ahead of your students. This will be helpful for your planning and your students' success. Your review of the materials just described and practicing the lesson activities for each unit will help you understand the concepts and terms. Reference the recommended resources and glossary in the course overview guide for additional support. While you don't need to be an expert at coding or using MakeCode and microbit, you need to know enough to present the content and be willing to learn with your students. The tasks in this section will help you get a baseline level of understanding. Before the first unit, it's important to get familiar with the layout and functionality in MakeCode. In the course overview guide, follow the step-by-step instructions to practice importing a project, saving a project as a hex file, and publishing a project to get a sharing link. Learn the layout of an open project, which is the view you and your students will work from the majority of the time. Then start coding. If you're new to coding, start with the flashing heart tutorial found in the tutorials section of the home page. And if you have some experience, jump right to the first coding activity in Lesson B of Unit 2. You also need to understand the basic functionality of the microbit by reading about the features at microbit.org/guide/features. Then follow the step-by-step instructions in the course overview guide to practice downloading a MakeCode project to the microbit. Starting in Unit 5, sound and movement with the microbit are introduced, so be sure to give yourself some extra time to learn that functionality beforehand. Links to tutorials are provided in the course overview guide as well as the Unit 5 Educator guide. If you decide to use the MakeCode for microbit Windows 10 app, it's recommended that you download the app to all computers, laptops, or tablets before starting the course. Or you could lead your students to do this in Lesson B of the first unit when students first start using MakeCode. For additional support as you prepare, please see the recommended resources on page 22 of the course overview guide. Thank you for introducing your students to computer science with Microsoft MakeCode and microbit. Best wishes and enjoy this fun, engaging course.